Hey everybody, my name's Conrad Reif, and I am here to share my project about the SDL2 and OpenGL libraries using C++. Um, so SDL2 is a library that's written in OpenGL, and because it's written in OpenGL, it's really easily integrated in OpenGL. It can handle events such as like the mouse event, so mouse over and click events. You can press keys. You can use joysticks, any kind of joysticks. I had an internship over the summer where we used RC stick and also integrated Xbox controller using SDL. It has related libraries like the SDL mixer, which is for audio. It's pretty primitive, but I mean, it's an old library. And also the SDL image, which is for rendering textures. And SDL2 is a pretty good beginner library for rendering graphics. It's not very good with 3D graphics. I don't know any project that uses 3D graphics in SDL2, but it is great for 2D graphics if you want to learn how to start rendering graphics to the screen. OpenGL is a more complex, detailed designed API for rendering 2D and 3D graphics. It interacts directly with your GPU, and it uses vector math and matrices to render these graphics. So it does a lot of pixel manipulation we'll talk about in a minute. It also uses a side language called GLSL, which is to define the shader attributes. And also it has these other libraries that make it easy. These are made by all the people that created OpenGL and also other programmers that made useful libraries, and that's GLM, Glue, and the GLFW, and they are exactly as they sound. So how do they work together? Well, in this example right here, we have an SDL window object called window, and it's being assigned to a method called SDL create window, which is also part of the SDL library. And all we have to do is include that highlighted part, the SDL window OpenGL, and we have integrated completely SDL2 and OpenGL together. So it's just as simple as that. So what makes OpenGL special? Well, OpenGL allows for pixel by pixel manipulation, and that's by using that GLSL library, which is OpenGL shading language that I mentioned a minute ago. In the bottom, there's an example of this. We have at the top, you can see that GLSL is very C-looking language. At the top, there's a float time variable. And although it shows that it's defined in this GLSL, it's actually being completely manipulated by the C++ engine that I've created. So when you run the engine, it assigns this time inside this GLSL a value. Then it assigns the colors according to that time. So that vec4 is actually an RGBA, so red, blue, green, alpha values, and using a sine wave. And it generates this texture. As the program runs, this time variable increments and gets reset over and over again. So that purple then turns to pink, then turns to cyan, then turns to purple. It's making this wave effect with colors, and it's really neat. So what are shaders? There's three types of shaders, and I'm just going to go as brief as possible with these. I'm going to skip the geometry shader because it is really optional. The vertex shader allows the programmer to assign vertices onto the map of the screen. So we can give the vertice a point, and it just renders that point. It doesn't draw triangle. Sometimes it does, depending on your computer, but it doesn't draw any lines between these vertices. It literally just draws a dot on the screen. And then the fragment shader, that's when it draws the lines between these points, and it renders colors in between. And it does this by a process called interpolation. So we can do something like glow effects, textures, and waves with this fragment shader. In this example of interpolation, we can see that we have on the left triangle, we have three vertices, each of the color red. And what interpolation does is it compares two vertices and says, is there some common ground we need to come to in the middle? There's some algorithm that does this for you. So since we have three red vertices, between vertice 1 and vertice 2, since they're both red, the common ground's red. So same thing with the other three, all the combinations. It's always going to be red, so we just drew a red triangle. Interpolation is a good example of interpolation, or something that's very visually helpful, is the right triangle. And that is there's a green vertice in the bottom left, there's a blue vertice in the top middle, and there's a red vertice in the bottom right. And you can see that the blue and the red vertice come to a common ground of purple, the red and the green come to a common ground of like that yellow-orange color, and the blue and the green come to that cyan color. So interpolation is that gradual process of changing colors that OpenGL does completely automatically for you. Here's some references to help you if you need help with the with learning OpenGL and SDL. I've included documentation, videos, more documentation, and also a cool website that you can actually practice your own GLSL and create. It's kind of like CodePen if you ever use that with web development. That's what this is for GLSL. Thanks for watching.